475 building blocks number 3. So if you have attended the 2 previous to this, you'll notice that we're going on a bit of a theme here with these sessions. So we're diving into really specific topics with regards to high performance building. So if you haven't checked out the first 2, being about windows and applied rafter details, definitely check those ones out. Those are with Nick, who's our product consultant in the States. And this one's going to be all about mass timber construction. So first, introduce myself. My name's Aaron, and I'm the product consultant for Eastern Canada with 475. So Ontario, Quebec, and the Maritimes. Hopefully there's a couple of people representing those areas on the call. And if so, feel free to connect with me via email or phone. I've been with 475 for about 4 years now, with most of my experience before this being working for a custom builder up in Collingwood. And just really quickly, if you're new to the website and new to 475 in general, have a look on our website where you can see a whole bunch of stuff that we've got. So you can really get introduced to our world here on this website. We've got all of the products there. We've got spec sheets, install guides, and then also a bunch of knowledge resources to supplement that. So that can be blog posts, technical case studies, building science topics, and one of the big things that we're known for are these ebooks. So these ebooks are 60 to 70 page documents that have a whole bunch of tried and true details illustrated really well on them for a whole bunch of different types of construction methods. So we've got one for historic masonry, we've got one for wood framing, we've got one for mass timber, of course, and then a couple of the other more fancy high performance wall assemblies like double stud and I-joist outrigger. So really what they're boiling down to is they're trying to help a designer or a contractor or even a homeowner figure out what the best practices are for continuity of those 4 control layers in an envelope. So good air, water, vapor, and thermal control. So as I said before, we're going to dive into mass timber today, which is really fun. I'm sort of the in-house mass timber nerd on all of this, so I love talking about it. And I have really liked seeing the growth and popularity in mass timber throughout North America. And 475 has been a part of some of those projects, and we've really enjoyed it. So starting off with things very introductory, what is mass timber? I'm not going to go through too much detail here, but ultimately we are replacing steel and concrete with a mass timber structure. So we're starting to see as mass timber is growing, it is starting to get into segments that were really previously dominated by steel and concrete. So we're starting to see mass timber on a lot of sort of 5 and 6 story mixed use buildings. We're starting to see it used on institutional buildings. And now with all these code changes, whole bunch of 12-story and 18-story mass timber buildings coming up. When we boil mass timber down from a building into these elements, you'll see that there are really just a few that can help to build the entire structure. So 3 of the most common ones are CLT, glulam, and NLT, with CLT being cross-laminated timber. Essentially, it's a bunch of 2x6 lumber with 1 layer vertical, the other one horizontal, and then that's kind of all glued together and repeated for 3, 5, 7 plies. This is oftentimes a floor system or a wall system. And then that is supported by glulam columns and beams. So glulam, again, it's been around for a bit, but the name suggests exactly what it is. It's pretty much just a bunch of glue and laminated 2x. And then NLT is kind of the OG mass timber. It's been around for a while. It's been around in the building code for decades now. And it's pretty much just a bunch of nailed timber. So it was really popular a few decades ago in kind of warehouses. So if you're doing a warehouse restoration project and you rip down the drywall, you might notice that you've got an NLT wall there. So we're starting to see a big revival in NLT and mass timber in general. And we've actually got some pretty cool looking NLT ceilings in our new office in Brooklyn. So why use wood? There's a number of different reasons. One of them being purely aesthetic. So wood is a natural building material. It connects us with our environment, and it just generally looks really good. This was one of the first mass timber projects that I ever heard about, and I just love this picture because I used to live in Banff, and I would always walk across this bridge to get from the hotel to the town. And I never actually realized that it was mass timber until I found out what it was and I got into high performance building. So just generally speaking, this building or this bridge would look a lot different if it was made out of steel and concrete. And that goes for buildings as well. So when we use natural materials and good daylighting, there's a lot of health and wellness benefits there. There's a big carbon sequestration aspect to using wood as well. So the concept of embodied carbon is starting to become really prevalent in architecture. And mass timber is a great way of potentially putting some of that into your buildings. So essentially what's going on here is from the time that tree is a sapling all the way up to the time when it's a mature tree ready for harvest, it's undergoing that photosynthesis process. So it's taking in that CO2 and breathing out that O2. And then where does that C go? And the CO2 gets stored in the trunk. And then once that gets harvested, it can get put into the building, and then you're effectively storing carbon. So this is especially true for FSC certified woods or CLT panels that are using FSC certified lumber, because one of the big differences here between wood and steel and concrete is that steel and concrete are really, really resource intensive. So if we can find a way of reducing the amount of steel and concrete in a building, we can really drastically reduce the overall environmental impact of that building. There's an economical case for mass timber as well. So when you're comparing it to things like steel and concrete, you can reduce the construction timeline by up to 30%. And then this time saved, as well as the lower material cost, can result in a 28% cost savings. So this comes from a technical case study that was done by Woodworks back in August 2019, which is just generally also a really, really great resource for getting any information on wood construction in general. So how is wood different from steel and concrete? This slideshow presentation is all about moisture management plans. So that's what we're going to be talking about primarily. And this is really the difference. So wood is a sponge when it comes to water. So thank you very much, 475HQ, for making this video. And this is just a time lapse demonstrating what can happen. So there's a couple of things that you can see from this video. One of them being that that wood is actually actively soaking up that water. So that's one consideration to make. And then also, if I were to play it again, take a look at the plywood on the left there. So you can see there's actually quite a bit of expansion as well going on. So as that wood is taking in that water, there's a huge amount of growth too. So when we're building really anything with wood, these are definitely a couple of things to consider because we want to be able to manage that moisture so that these things don't happen. So I'm trying to get to the other slide here. It's not letting me for some reason. So the scientific term for all of this is wood is a hygroscopic material. So that just means it has a capacity to actually store water. So wood stores water in two different ways, one of them being bound water and then the other one free water. So this image on the left here is a microscopic image of wood. And you can see that it's kind of like a bundle of straws, right? And these straws are called tracheids, and they are there for when that wood was previously a tree and it needed to bring water all the way from the roots to the very top. And when we're talking about how wood transports water all the way up, it's very, very efficient. So these straw-like structures really know what to do with water, and they can store it actually within the cell wall itself or in all of the spaces in between. So what better way to illustrate wood being a sponge than to actually use a sponge? So this is an example of free water. If I were to pause it, so There's nothing preventing water from leaving this. There's a bunch of water all in the free spaces here. So it's not held by the structure, but bound water is. So you see there's nothing in the spaces, but there's actually quite a bit of moisture still embedded within the structure. So knowing this relationship between bound water and free water will help us to determine what type of water damage can be seen in a wood structure, and then also what we can do about it. So that's what we're going to be talking about for pretty much the rest of the presentation. So in terms of the types of water damage that you would see, starting sort of from minor to major, you can get staining, movement, mold, checking, and decay, which is something you definitely don't want to see on a mass timber project. But you really want to be cognizant of when any of these are happening so that you can avoid them for sure. So staining is usually one of the first signs that you would see to indicate that you are getting some water damage. And it can be for a number of different reasons. So for instance, this is probably just a bunch of muddy boots on site creating staining. But this is a really important one when it comes to mass timber because the panel seams are actually really, really sensitive to moisture because that's where those straw-like structures sort of begin. And when we're looking at this photo, that's exactly what we're seeing. So we're seeing some amount of water getting into that panel seam, and then it's getting soaked up by the end grain and getting drawn further into the panel. And then after that, you get these pretty nasty stainings because the tannins are drawn up with the water as well. And then they have to get scrubbed off or sanded off. So this can result in quite a bit of remedial work in a mass timber project that you definitely want to avoid. And then staining can also be from a wood to metal interface as well. So that's exactly what's happening in the center picture here. So you've got hardwood plank and a bunch of nails punched through it. And as these nails are oxidizing, it's creating these black marks that sort of seep through the wood. So as we're seeing more of these hybrid mass timber projects, it's really important to have some sort of treated metal so that this doesn't happen. Movement is another big one. So this is when there's an increase or a decrease in the amount of bound water in the wood. So bound water will either increase or decrease the structure, and then free water will do some other things. But effectively, wood can warp, it can change size as more water enters or leaves it. Mold is another really big one. So this is when there's a degree of free water in the wood. And this free water is, free floating. It's there just having a good time. And it's a really good breeding ground, unfortunately, for microbes. And this is something that you want to avoid as a health risk for sure. Then checking is what happens when you get these rapid fluctuations in moisture content. So this can affect the structural integrity of the wood. And then decay will also definitely affect the structural integrity of the wood, and this is, pretty much mold when it's really had its day. So then ultimately, how do you prevent these? You don't want to see any of these on your mass timber project. And ultimately, it comes down to controlling the moisture content at the entire point of the construction timeline. So the amount of the moisture content is the amount of moisture contained in a material as a percentage of weight. And I like to illustrate just how much this can change in mass timber and in wood by thinking about driftwood versus a deadhead that you would find at the bottom of the lake. So, picture yourself maybe walking along a beach on a nice sunny day and you see a piece of driftwood baking in the sun and you pick it up and you're always surprised by how light and how brittle it is. But then on the flip side of that, say you're fishing on a lake and your lure goes a little bit too close to the bottom and you pick up a little twig, but you think it's about a 4 or 5 pound bass, right? So it can really change depending on how much water's in there. And this applies to mass timber because you want to have kind of a middle ground when it comes to the amount of moisture in there. So you don't want to be too dry and you don't want to have too much moisture in there. You want to have a range of about 12 to 16%, as we're seeing through research getting done on this. So why does this range exist? Again, it has to do with the fact that wood is that hygroscopic material and the amount of moisture will kind of dictate how the wood will take in the water. So mold is a big one. This is from the CMHC. So indicates that you want to keep your moisture content somewhere below 19 to be immune to fungal growth. But as soon as you get more than that, you start to introduce free water into the wood, and then you can start to get new growth of mold. And this is especially true for when you're using engineered wood products. So generally speaking, the more processed that wood product gets, the more susceptible it is to mold growth. And again, this has to do with those tracheids in the wood structure, those bundles of straws that you're seeing on that left photo there. So as the wood product gets more processed, these tracheids start to get interfered with, and as you start to introduce glues and stuff like that, you can start to interfere with the normal drying capacity of that wood structure. And then in terms of drywall encapsulation and paper, paper is pretty much as processed as you can get in terms of a wood product. So you can start to see mold grow on the back of that paper-faced drywall within days. And that's why it's especially important for mass timber, because I know in the Ontario building code for sure, and a couple other building codes around the states, you need to have some degree of encapsulation of the mass timber in drywall for the fire code. So you wrap something in 2 layers of drywall, you want to make sure that that mass timber is dry enough so that you won't get that mold growth. And FP Innovations has actually done a huge amount of research on mass timber so far. And they actually did do a study on drywall encapsulation, and they found that 1 layer will reduce the drying rates by about 20%, and then 3 layers will reduce it by about 50%. So we talked about what happens if the moisture content gets too high, and then there's also something that can occur when you get rapid fluctuations in moisture content, and that's this checking issue again. So when it comes to just wood in general, you can start to get these fractures because that wood constantly expanding and shrinking will weaken it. And it will also weaken the CLT panel in general because those glue lines will start to fracture, and then this can affect the structural integrity of the panel. This is just a zoomed in photo of what you can see here. So then how do you control the moisture content, right? I showed a bunch of scary pictures. I didn't want to veer anyone away from doing mass timber. I absolutely love mass timber projects and I want them all to go successfully. And there's definitely a way to do it. But you have to be cognizant of controlling that moisture content. And that comes in with a moisture management plan. So this is where either myself or any of my colleagues can come in, any of the other product consultants, to help the team in developing this. So we can, maybe have a pre-design meeting on all of this to essentially assess the risks and figure out what to do. So when developing a moisture management plan, it's a 3-step process, and number 1 being assess the risks. So this is when you get all the stakeholders on a table, ideally, and you ask a bunch of questions related to what could happen in terms of moisture on your project. So a couple of the big questions to ask yourself are: where are you building, when are you building, and then how long are you going to be building? So big difference between building in the winter on Vancouver Island versus building in the summer in New Mexico, but also still important considerations to be made for sure. Understanding the method is a really important one. So this is understanding how the building will be constructed. And one of the big things to discuss with all of this is that mass timber buildings get constructed 1 floor at a time and kind of this stacked floor sequencing. So you can see it goes from 1 floor to 3 floor to however many floors you're building. And probably the most important consideration in all of this is that whatever your top floor is in your mass timber project, it's kind of acting as the temporary roof. So it's protecting all of the other floors below it. And just based on what you want to do in terms of a construction timeline for a mass timber project, oftentimes, as say in the case of the far right here, as your 10th floor is going up, you hopefully already have concrete topping on a lot of these lower floors, or you've maybe even also put a prefabricated wall assembly around the entire thing. So you really want to start closing in and drying that mass timber project as quickly as possible. So it's important to have that temporary roof actually doing something as opposed to potentially seeping through to the lower floors and then creating a lot of schedule delays. The connections is a big one too. So as you saw previously in that picture with all of the staining at the panel seam, these seams are really, really pesky when it comes to trying to figure out what to do with them. And they're just a really moisture sensitive area as well. And that's because there's so much exposed end grain here. So this trough, pretty much all exposed end grain here. And the seam, there's a lot of exposed end grain. And then, to cap it all off, oftentimes you've got a plywood spline here, and plywood can soak up a lot more moisture than CLT. So step 3 is determine a solution. Once you've figured out, how you can build it and where you're going to be building. And there's a couple of things that you can do really early on in the design phase. So one of them being you could try to see how much you can prefabricate your project. And this could be either using a panelized system like what Timber Age does, or even a modular system, which we've seen Kolesnikov do. And this is a really fantastic way of making sure, just generally speaking, that you're not going to see as much rain on the project, because the more you can do in the shop, the quicker the project can go. And that's the same case for the panelized and the modulars as well. Also related to just getting the thing up as quickly as possible or limiting the amount of time that that mass timber is exposed, you can do something like just-in-time delivery. So this is really good for certain projects, but there are some projects where it just isn't favored. So for instance, if the project is in a really urban area and it's really difficult to maneuver these panels around, or if you're in a really remote area that's far away from the factory, these are considerations to be made in all of that. So in terms of what you can do on site, or in terms of like a material that you can use to prevent moisture from getting further into the panel, we've seen a lot of water repellent coatings used. So these can be either applied in the factory, they often are, or they can be applied on site, with the concept being put something hydrophobic on the very top so that water can't get further into the panel. And this works for some projects, but in perhaps places where there's intense rain or there's a lot of job site traffic going on, these water repellents will start to degrade over time. They could get, continually rained on, and that kind of dissolves them a little bit. Or just generally people are moving scaffolding and they're walking on the panels which have the coating, and this can start to take it down a little bit. So there's been a whole bunch of research on this kind of topic for FP Innovations, and this is their result from that. So what they did in this study was they took 6 really common water repellent coatings and they tested to see essentially their durability. So they compared the wood moisture content, which is on the y-axis, and they just expose them for a long time. So on that x-axis, you've got the amount of time that is exposed. And you can see for all 6 of them that there is a period of time where you do get quite a fluctuation in moisture content, and also moisture content over 20%. So you're putting it at risk. You can also tape the seams too. So taping the seams will help to effectively waterproof those really sensitive areas very well. And there's a couple of important considerations to be made. One of them is you want to make sure that you have a tape that's wide enough so that it sufficiently covers the spline. And one of the issues with the taping of the seams is that there's kind of this selective sealing issue that can go on. So sometimes maybe it's unclear as opposed to what should get sealed and what shouldn't get sealed, which can lead to potential for water infiltration further into the building. So one of the things as well that I've seen people do is they'll use an impermeable membrane. So they try to get rid of that selective sealing issue and try to make sure that things stay as dry as possible by just throwing an impermeable membrane on there because it's also going to be more durable than a coating. But one of the things that's an issue with that, especially the impermeable ones, is that water will always find a way. So it's gotta it's going to figure out a way to get in between that CLT and the membrane. And then from there, it's either got to dry through, maybe 5 plies or 7 plies of CLT, or it's got to dry through a really rubbery membrane. So if water gets trapped there, you have the potential for decay or mold growth or really anything. So this is where vapor permeable membranes come in. So FP Innovations, they have also done a study on all of the different types of moisture management materials that you can use. And they found that the continuous self-adhered vapor permeable one was the most effective, just because it's highly durable, it's ponding water resistant, but in case, if/when water gets underneath it, it can dry out to a degree. And this is also just another really great graph from an independent study out in Sweden. So what they did was they modeled unprotected CLT versus CLT that's protected with a vapor permeable membrane. And it's very similar to the graph that we saw previously with moisture content on the y-axis, and on the x-axis, you've got accumulated rain. And there's a couple of things that you can really see from this graph. So one of them being, again, while the CLT is unprotected, you get moisture content above 20, but then you also see these big fluctuations in the moisture content too. So I don't know if you can see my cursor, but you kind of see this wave action, right? It's like a sine wave of wetting and drying. So you want to avoid this as well because of that checking problem. And you find that the CLT that's protected with the vapor permeable membrane does a good job of not only keeping the moisture content below 20%, but it also really reduces these huge fluctuations in moisture content as well. So it keeps things a lot more stable. And these were all the considerations that we made when we developed ADHERO VISTO. So this is a self-adhered membrane that's specifically designed for temporary weather protection of mass timber. And this is just a photo of it getting used on one of the projects. You can see it's very, very clear. So there's a couple things that we considered when we were figuring out, how we wanted to develop this product. There had been a couple of mass timber moisture management membranes out already, and people had been using them and stuff like that. So we wanted to sort of take what we could from the real world and from case studies and put it into the Visto, to make sure that we had a really good product. So one of them being, we wanted it to be really, really transparent. So this could be because there's usually a high level of prefabrication in these mass timber projects. So there's going to be, kind of pre-cut holes everywhere and stuff like that. So we wanted to make sure that it was transparent so that when we were covering it, we weren't blindfolding everything. And then another thing is you might see fastener layouts or something that will have to later get put in. So yeah, it's beneficial for sure to have something transparent. And then when it came to figuring out what to do in terms of just the water resistance in general, we really wanted to strike a balance between the Visto being really, really ponding water resistant, but then also just that little bit permeable, just so that you can get a tiny little bit of drying from the outside. Because generally speaking, the more vapor permeable the membrane is, especially on the flat, if you get water ponding on that membrane and it's highly vapor permeable, there is a potential for seepage through that. So we wanted to have it a little bit more closed for that, but then also open just in case there was a buildup of moisture underneath the membrane for some reason. So like every other adhesive in the Proclima system, it bonds to pretty much anything. And it's a pressure activated adhesive. So definitely use your press fix or a broom or a roller to smear that adhesive onto the substrate. Couple cool things for the contractors as well. So we wanted to design Adhero Visto to be really, really grippy, even in wet conditions. So feel free to get in touch with any of us if you want a sample of this material just to see how grippy it is. Because that's one of the main things that we wanted to have in the membrane. And then another thing too, it can really show chalk lines as well. And then it's also got industry-leading nail tear resistance and tensile strength for when scaffolding is rolling around it and stuff like that. So yeah, the last thing you want to do is, after you spend all this time putting the membrane on, you don't want to spend any more time kind of patching it up as holes start to accumulate and things like that. So we wanted to make sure that it was going to be able to withstand, pretty much construction level duties, I suppose. So then what about the walls? So this is where Adhero 3000 can come in. So this is been around for a while. It's very similar to the Visto. It's used on a whole bunch of different projects, and it is just slightly more vapor permeable and has a better UV resistance. Same adhesive as always as well. Okay, so yeah, we pretty much talked about everything I'd like to at this point. We've talked about why you would want to use mass timber. We've talked about the risks associated with using wood in a structure, and we've also talked about what you can do about it. So I want to finish things off just by talking about a story. So this is going to highlight two different types of moisture management, the one that's planned ahead, and then the one that's kind of trying to alleviate things once they've already happened. So it's like treating the symptom versus trying to be a bit more proactive. So we'll talk about the treating the symptom first. This is a mass timber project that I went out to in April and I visited. And you can see no taped seams or anything like that, no membrane. There's no coating on this either. And even in April, the panels had only been exposed for a couple of weeks, and you're starting to see the staining show up. So this is the first sign that you might be getting water damage on your project and leads the potential for even greater water damage. And then fast forward to June, so they probably figured out that a lot of this moisture was seeping in through the end grain of the panel and starting to stain things, and they realized how much extra money and sanding it was going to cause to remediate all of it. So they started to tape the seams all the way around. You can see they're taping the seams on the top floor here, but if you look right there and there, you can see the small little holes that they didn't seal up. And you can see that there's staining still coming through there. Fast forward to August now. So this is another site visit. And you're starting to see that the CLT's probably been exposed to a number of wetting and drying cycles. So you're starting to get this checking of the lumber and then also a checking between the glue lines. You're getting these glue line fractures. And then still, they've run into a couple scheduling delays at this point, trying to make sure that this mass timber gets dry enough. And they've entered really the wet and cold season. So in the winter time, this mass timber is going to dry out a lot slower. You start to see some pretty heavy staining here that'll have to get fixed because the whole point of the mass timber is you want to be able to expose it. You want to have it looking good. So they've resorted to renting these big industrial heaters to heat everything up. I've also heard of a couple projects use hydronic lines and just pump hot water through the panel to dry it out. So when we're thinking about the added expense and all of this, it's pretty crazy when it comes down to it. And the reason why they have to do it is because they have to dry it enough so that they can put the concrete topping on and encapsulate it. So it has to be below 19%. And still a bunch of staining getting through at some point. So they used the Visto at the very top floor. This was installed maybe a couple of weeks before I went there, and it was just a little too late, right? So the panels are probably already just soaking wet, and they tried taping the seams. They put the membrane on a little bit too late, and now they're having to resort to having a crew float around all over the place and take moisture readings so that they can make sure that the panels are sufficiently drying. So there's another project that I want to talk about, one that's definitely a little bit more easygoing. And this is the second mass timber building in New York City. So this is one that just went with the Visto right away. I'm not saying in this that Visto is the solution for every single project, but it could really, really help for any mass timber project that either has a big footprint, one that could get exposed to rain for a long time, or say maybe it's a public project and it's going to take a little bit longer, or if the contractor isn't as experienced with mass timber and they don't know the workflows quite as much, this could definitely be a good solution for you. So something like this, right? If you're to tape the seams, you might miss a couple of these, but you can easily just throw a membrane over top of everything. It really eliminates the guesswork. Site visit in August here. Things looking pretty good. So not much staining at all on the ceiling there because the Visto's on every floor. You can see it's holding up pretty well too, just generally speaking. No big scuff marks from scaffolding or anything like that. Still looking pretty good here. And then let's not forget this was Brooklyn in September too. So you can't really plan for these events, but they got 10 inches of rain in 3 hours. Just crazy stuff. Super sad to see. Our headquarters got flooded as well, I think, on this one. But you just never know what's going to happen sometimes. So they went afterwards to the site, and they probably had to do a fair bit of squeegeeing. But after all that rain, still things looking relatively good. And then, the project going sort of on schedule. We were able to visit it in October as a crew for our annual general meeting. Things looking pretty good. I believe people are living in there now. And that's just a picture of all of us. So yeah, definitely for sure, feel free to reach out to me or any of my colleagues here with regards to moisture management for mass timber. And thank you very much. I hope that was a good presentation for